Domain and range is are two separate words that we need to know. So domain and range. Okay, so let's highlight those. Domain, as we talked about before, is the set of the first coordinates in an ordered pair. Okay, first coordinates. Now, you might just go, why don't we just call it X? Because not every time is it going to be X and Y, right? Like you might have the profit versus time, so it'll be a P and T. It might be height over meter or height over distance, like so something else. So it's not always going to be X and Y, so that's why they hesitate saying X and Y. It is like that though. So the first coordinate is like the X coordinate. So for yourself, if you go, you know what, X is usually the first one, and then the range is always the second, right? So we talked about this before. So second, how wide it is and how tall it is. So the range is usually the Y. Now, again, they don't like to say X and Y because the variables change, right? It won't always be X and Y, but it has that same meaning. So the first coordinates is the domain. The second coordinates is the range of the ordered pair. And whatever that ordered pair is, it looks like this, X, Y. Okay, so if it was profit and time, it might be T and P, something like that. So you're going to have different things. Now, that's why they call it first and second. Okay, so that's why if you're wondering why it's not just X and Y. Now here, we're going to state the domain and range of this. The curly brackets, we talked about this last class, right, means the set of, right? It's the set of, and you're trying to do that pretty little curly bracket thing like that, right? So it's supposed to look like that. I know it's hard to draw. It doesn't have to be perfect, but try your best. You can't just make it into a round bracket though, right? So it has to be the curly brackets. So the curly brackets, and then I have these coordinates set in there, right? These coordinates are set in there. So that means these three coordinates are my function, right? Or not a function, depending on if it is a function, but those three make my relation. Okay, so those 3 points. It's not always going to be a parabola. Right? So I can't always draw it. It's just going to be 3 points, and I listed them for you. So I want you to tell me the domain of that. Remembering the domain is the x values. You're telling me what x values occur when I draw those 3 points. And what x values occur when you draw those 3 points are this. Now watch. Curly bracket. Try your best. And you're just going to list the set of those. So you can do this. You can go 0, 2, and 4. And usually, actually, sorry, I usually put x as an element of on the outside there. So x is an element of. So remember how we learned the E, that funny E thing means element of? So x is an element of, and then it's just a list of 3 points. These points must be listed in increasing order. Okay, so in increasing order, so 0, 2, 4, left to right on a number line, and no repeat of the numbers. So if I use a number twice, I don't want you to list it twice. Okay, so the range, we're going to try the range now, and we're going to say y is an element of, and it's just a set of points. Just a set of points. So you're going to say y is going to be, and it's 1, 3, and 5. Like that. 1, 3, and 5. Okay, and that's it. So you can see it's in increasing order, left to right on the number line, and no repeat. So let's try that again. If I gave you more coordinates, right? So more coordinates there. I'm going to do the domain. So I'm going to go x is an element of, and then list it. The set of -3, -2, 3, 8. Oh, that's already in order for me. So -3, -2, 3, and 8, like that. And then my range, my y, is going to be 1, 1, 2, 0. But what I say about repeats, don't repeat yourself, and I want it in order. So it's going to be not 1, 1, 2, 0, it will be 0, 1, 2, no repeat. Okay? You don't want to repeat, it's just like you're being redundant, so don't bother saying it twice. All right, so that's your domain and range. So if I give you a list of coordinates, just list the points back again. Not the points, but the values back again. You list it back. The second type, or the next type we're going to do is graphs. What if I graph it and I want you to describe the domain and range? So one more time, what were you talking about last time? The domain is left to right, right? The x values, and the range is how tall it is. So left to right, this graph starts at 1, 2, 3, -3, right? Correct? And over here to 3. So left side of the graph is -3, and the right side is 3. So it's going from -3 to 3. It's got a line going in between. That line in between, that it means every single value, every single point in between there is included. So you cannot list that. So some people go, can I do it like this? You can't. To list every single point in between would be impossible. You'd have to go -2.9, -2.99, -2.90749. How would you even begin to list? It'd be an infinite number of points. So instead of doing that, you say for your domain that it's going to be x is an element of, yes, real numbers. So that's the real number part that we were talking about yesterday. So real, capital R. You can double bar it. Again, some teachers do double bar R like that because it's like making it bold or capital. So real number. And real number means it's every single little number in between. That's why we say x is an element of real. I didn't need to put it up here because I was just listing the values, right? There's a few values. So I didn't need to say real number because it was just the numbers I listed, right? So you don't have to say that. So here you want to say real number because it includes every single value in between. From, and I said use such that. I'm trying to get you used to some of these symbols. I use such that when we do the calculus course, so I like to start to introduce it this year where we're like, or in last year as well, in the grade 10s where up and down means such that. So it's like you're reading a sentence. The set of x, which are the element of real numbers, such that, so it feels nice. It's like a sentence. So such that, and then you're going to say, x goes between -3 all the way to 3. So I'm going to go from -3, and I'm going to do the little greater than, less than sign here, there, like that. So that is saying that x is between -3 to 3. And you can see it's open towards the 3, right? Because x is greater than, towards the x is greater than or equal to -3. And look, it's closed this way and less than or equal to 3. It's saying two things at once. X is greater than or equal to -3 and less than or equal to 3 at one time, at the same time. So between those two. So x is between. I always like to list it left to right on a number line. Again, next year you're going to learn another type of notation, and we always write it left to right. So I always say get ready this year by writing it left to right. I don't want you to write it this way. So what I mean by left to right, is I don't want you writing it this way. Like that. Okay, I know it means the same thing, but see how this number on a number line, you would have -3 here and 3, so that's what I mean by left to right. Okay, so I don't want you writing it backwards. I'd rather you write it left to right, so it's number one. It's a little easier to read, and also because next year another notation that we have, it has to be written left to right. So just get in your head left to right, left to right. Question? Yeah?
So the first symbol means x is greater than or equal to 3, and the second symbol means...
Yep, you're reading it all together. So you're saying x is greater than or equal to -3, and it's less than or equal to 3 at the same time.
Okay.
Right? So it's between those two numbers. Some people go, x is between -3 and 3. Exactly. Right? But that greater than and less than symbol, that's what it means. Okay? And then make sure you close it up, got the curly brackets. You will lose marks every time if you don't write curly brackets. Some people avoid it and go, I'm just going to not write it. If you don't write it, you're going to lose marks every time. Okay, so you do have to write it. Don't avoid it. You can do it. It doesn't have to be perfectly beautiful. Just look like the curly bracket. Okay, let's do the range. Okay, so for the range, we're going to do y is an element of and the real numbers. Okay, and again, let's look. The y is going from over here, again, -3 and 3. From the top point to the bottom point, and this is easier now because we just did it. So it's going to be from the -3 to the 3, and you put the y in between. And okay? All right. So this next one's a parabola, right? It's our quadratic function. I just graphed one for us. And the domain, as we know from last year, right? We talked about this, and we have that it goes left to right. Like the parabola always keeps going left and keeps going right. So we know that this parabola keeps going both directions, never to stop. So the way we write that is we say x is an element of, and then we say real, and then we close her up, and we say, yeah, everything. Everything real. Everything you ever want it to be, that's what it will be. So X is everything. So that's how you say X is everything. Yeah, X is an element of real numbers, no restrictions at all. Okay, let's try the range. The range we're going to do, now Y, so again, range is the Y value, so it's the bottom to the top. The bottom here has a bottom restriction, and the top it keeps going. That's why I said it's important where you put arrows and where you don't put arrows. So this keeps going up, 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 no restriction, but it starts here, right? And we know for the quadratic function, the parabola, it opens up or opens down. So this one's opening up, starting here at the -2. So that means I'm going to write it this way. So I'm going to say Y is an element of the real such that, I'm just getting us used to that symbol, such that Y is greater than or equal to -2. So Y is greater than or equal to -2. Any questions? Yeah.
Does it matter which way you write it? Like if it's -3 is less than or equal to y, or -3 or y is less than or equal to 3? Like does it matter which order you put the 3?
These two?
Yeah, and so you put the y first on range, but then on that range.
Well, because there's only one restriction, right? So I started with kind of the variable. So I like to start with the variable. So instead of saying -2 is less than or equal to y, I like to start with the variable.
Okay.
Yeah, so typically you start with the variable. It's kind of standard. Here, you had to say it's in between, so that's why you put it in between. Yeah, there's only one way to write it, yeah, for that. For this one, there's only one way to write that one. It has to be in between. Yep.
So right now, are we just trying to like say, like, I don't really understand like what we're even really doing.
Yeah, this is what domain and range is. Domain and range is describing the graph.
Oh.
Yeah.
So we're just like describing like where, like what the x and y are.
Yep, where the graph exists, right? So domain and range is just describing where the graph exists. Yeah. Okay, flip over, next page, try it again. Ready? Okay, so try it again. This one, we don't know the function. Doesn't have to be a function that we know. I can draw anything. I can literally draw any type of function, and you'll see I do that. I start to just draw random stuff and say, hey, give me the domain and range. So it's not always a function that we know, have seen before. It can be anything. And you're just describing where the graph is. So for this one here, the domain of it is left to right. So you're describing the graph. Left to right, where does the graph exist? Well, it starts here and it heads this way. So I want to explain that with my domain and range. So my domain is going to be that x is an element of real. How do I know it's an element of real? Because it's a line. So anytime it's that line, I say it's an element of real because it's all the points in between. Every single tiny, tiny point in between. I can't list it. It's every real number in between there. Such that, and I'm describing that this graph, when I describe it left to right, so if you're describing how big this graph was left to right, it starts here at 3 and it heads to the left. So it starts at 3, heads to the left. So I'm going to say that x is less than or equal to 3. So I'm saying the graph is less than or equal to 3. And yeah, I always seem to start with the variable because I find that when I'm thinking of my sentence, I'm saying, where is x? X is that way. Yeah. All right, let's try the range. Okay, so for the range, we're doing y, and we're talking about how high and low the graph goes. So when you look at this graph, how low does it go? Forever, because it's got an arrow saying keep going downwards, and this one keeps going up, 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 right? So then, is there any restriction on my y value? No. So I'm just going to say y is an element of real, no restrictions, everywhere she goes. Yeah.
So is there no restriction because like since the parabola is like, kind of like facing sideways, it'll keep going like, and the arrows say it's going forever, like.
Yes,
up and
forever
down.
downwards, forever upwards, yes.
So that's why you don't have to say it's in between?
Yeah, because in between is this. in between is this. So see how that's stuck in between? So if I was to describe the graph, I'd say it's in between here and here. How would you describe this graph? You'd say it's to the left of here, but up and down, don't stop it. It needs room. So when you're
trying,
trying, yes,
all real.
yeah,
Okay.
yeah, right? You're trying to describe where the graph goes. So here, where's the graph left to right? You're saying it's from here to here, restricted. So you're going to have two numbers. So in this case, you're going to have two numbers bound by that letter, right? Around that letter, because you're going to go in between those two numbers. Here, you're saying it went one way. That's so you can see it's only one way. And this, you're saying there's no restriction. I'm just going up and down forever. Okay? So let's try it again. So domain for this one, in between those two numbers. This one here is at -4. And this one here, 1, 2, 3, 4, 5, right? So it goes -4 to 5. So the left bound here is -4. The right bound here is 5. So I'm going to say that x is an element of real. And x goes from -4. Now, this open circle, do you remember what we talked about last year? The open circle means, what does that mean? Can't equal it. Right? So it's an open circle on purpose. So when you draw your graphs, they have to be neat, right? So when you want a solid dot, you do a solid dot. This, you can't be like, oh, I like, you know how you write your name, and oh, I like write my name, and maybe write your name and say, or you say hi, you go hi, and you do a little circle there, and you go, it's the same as a dot, not in math. So this is a solid dot. You can't say hi and put an open circle. No, no, no. In math, we're picky. So an open circle means don't equal that number. You can go all the way to that number, but you can't touch it. So, and this is something you'll get used to as well, right? So open circle means don't touch that number. You can go all the way to -4, but just don't touch it. So it's like you're saying, just don't put your foot right there. So that means you're going to get all the way to -4. X is going to be there, but don't put equal. So that's what this open circle here means this. It's greater than it, but not equal to it. Not equal. And then this one, look, see when it's a solid dot, that's when you're going to go equal to the 5 like that. You see the difference? So that one's solid, so it's equal. This one's open, so you leave it like this. So greater than, but not equal. You don't put the extra line there. Is that clear? Okay, so that one's open. That one's equal to it because it's a solid dot. So you're telling me that the graph is in between -4 and 5. In between those two numbers. So that's why your x is in between the two numbers. In between the two numbers. I always picture it like that. For my range, how tall, right? How high does the graph go and how low does it go? Is there any restriction? What's the lowest? Always start from the bottom up, right? The lowest possible is -1, right? Right here. And it goes all the way up to 1, 2, 3, all the way up to 4. So that's -1 all the way up to 4. So you can describe that to me. It's in between those two numbers. So it starts here. Can it touch that? No, right? It can't touch it, so cannot. So it's going to be at -1, but don't touch it. So like this. Some people ask me, will it always be open on both sides of it? No. I'll show you another one later on where one of them, the X is maybe open and the Y is not. So I'll show you how that works. Okay, it's not always going to be matching. Some people go, will it always match? It won't always match. Okay, so we got the Y, -1, and it goes all the way up to, it's got stuff happening, it goes all the way up to 4. Right, so then here, and it equals the 4. So you're describing this graph saying it starts at -1, it goes all the way up to 4. Right? It starts at -4 and it goes all the way to 5. Again, when I started at -1, it was open, so I could not equal it. Cannot equal it. I got to the 4, but I could equal it because it's solid, so I can have it equal. Any questions? All right. So now we're going to go back again. So that the first one I listed some coordinates. If I give you a bunch of coordinates, just list me the values back. Say it's this, this, and this. Easy. The next one, I give you a graph. You're trying to describe what's happening to the graph. Another type of question is I can give you the equation. And you have to be able to identify what type of equation it is, what sort of equation it is. So this one here, we know in our heads, you don't have to name it, but in my brain, I'm going to think to myself, and I'm going to think, you know what? This is linear. Okay, this is my brain. You don't have to write that as part of your answer, but it is linear. This is a linear function. How do I know it's a linear function? Again, look at the exponents. Exponent 1, exponent 1. If they're both exponent of 1, that means it's a linear function. So that means it's a line that either looks like this, right, or like this. It's a line. So that's what I'm thinking in my brain. Oh, lines do this. This one and this one are two different lines, right? There are special lines that we learned way back in grade 9. We started that. Y equals 5 is my special line, and x is -3 is my special line. So let's just, I'm going to sketch it. It doesn't ask you to sketch it, but just in case you're thinking, I wish I could picture what it is. Y is 5 means this is y, right? And y is 5 would be here, so it's a horizontal line like that. Y is 5 forever. X is -3 means this is x, and x is -3 would be here, which means that it would be a vertical line up and down. Okay, so that's y is 5. Again, picture it. Y is always 5. 5, 5, 5, 5, 5. Here, x is -3, -3 the whole way. All right. So then these are all three linear. All of them are linear. We talked about right function, not a function before, but these are all three of them are linear. What do I want here? Domain and range. So for this one here, the domain and range for any line that's going up or down is always going to be what? So as you go left and right, and up and down. What's the domain and range for any line, whether it's positive or negative? Yes?
X is an element of real numbers.
Beautiful. X is an element of real. And also for the range, same thing, because it goes up and down. Y is an element of real. Beautiful. If it's a horizontal line, yep.
I was just gonna say, is that just for like diagonal lines?
Yes, for any line that has a positive or a negative slope. If it's a horizontal line, though, looking at the domain, it goes left and right. So yes, for the domain, x is an element of real. Like that. Okay, x is an element of real. But the y value for this very special horizontal line, what's my y value? 5, always. So why don't I just list it like I did with the point 5? It's the set of 5, nothing else. So just list it. Doesn't need element of real, needs nothing else because it is just the one number. So just go element of, and it's the set of 5, which is only one number. Okay, given that, try it again and tell me it for this one, for our vertical line, so domain and range. So the domain is that's it. -3, -3, good. And range? Y is an element of real. That's it. All right, so that's the line, all three cases, right? Our three different cases of the line. For the next row, these two are related. That one I'll talk about in a minute. So J and K. Both of those are what? We recognize? Yep. quadratic because of the squared, because of the squared. When you see the x is squared, it is a quadratic function. That one we just learned, right? So we're going to talk about that one in a minute, but let's look at these two here. So we know quadratic function, what's important is whether or not it opens up or down. Other than that, we know from last year that x is an element of real, keeps going left and right forever and ever. This one we know it is going to be opening down, right? So in my head, and then this one's opening up, right? So in my head, I'm thinking up and down. That's the only thing I need in my brain. Remember the bubbles here, those are my brain just thinking. It's not part of my answer, just thinking. So I know it opens down. I know that for every quadratic, the domain will be x as an element of real, right? Because it keeps going wider and wider no matter what. So for both of them, x is an element of real. For the range, this one opening down, so I'm going to do y is an element of real.